Welcome, everybody, to those who are new to join us. So we are just reviewing some ideas from last week. Yeah, so now we are going to move on. And if you have any questions or missed something from last week, you can find all the recordings to our meetings at youtube.techdreamers.net and let me know if you have any questions. Okay, so today we are going to begin talking about a concept called computer science, more commonly known as programming. It's this concept of coding and all these different coding languages and kind of what importance they have and, the importance that we discuss it now and learn about it. So obviously coding and knowing all these different languages is very complicated. You need to know exactly what to write and how to write it. Otherwise you end up with a bug. A bug is simply seen as a mistake in a code, and one little mistake in a whole code can be written incorrectly. So it's very important that kind of these ideas are not only learned correctly, but also not the concept of coding isn't jumped right into. So today, as a starter, we're going to use a program called Scratch. And this uses a technique called block codes, where instead of writing the codes yourself, you still get to choose which codes are used, but the codes themselves are picked out for you. And the reason this is significant is because, and makes things easier, is because you still get to choose what happens, but all the actions of what happens are preset for you. And coding isn't just about what is it says and what is done. It's about how it's done and where it's done and what it looks like and what size it will be. And that's why when you drag a block, it has all this built into it and therefore makes the learning process a little simpler. So yes, we will use Scratch. But before we begin actually using Scratch, I want to discuss a theory called the black box theory. The black box theory is one which discusses the relationship between the input and the output and what needs to be done in between in order to get from said input to said output. So how we can think about this is an algorithm. Something will always be happening in order to go from A to B. And this is our algorithm. So for example, if you want to go from a whole apple to apple slices, our algorithm is chopping the apples because there needs to be something in the middle that happens to get from our input to a desired result. So the entire black box theory will look like this. We have our input, we have our algorithm, what is happening, and we have our output. Does that make sense to everybody? I went over that quite quickly, so I'm just going to look in the chat if there are any questions. Feel free to let me. Oh, okay. Someone asking for me to repeat it. Yeah, of course. So the black box theory discusses the relationship between an input and an output. And when I say the relationship, I mean what is done to get from what we give a system to what we want to get out of a system. So always in coding is this process where we want an action to be performed. And in order for this action to be performed, we give it information, we give it the steps, we give it directions. So think about it as driving a car. You want to get from A to B, but in order to do so, you need to know how to turn on an engine, how to actually drive the car, and where to go, right? There's all these things you need just to get from your home to wherever you want to go. So the same thing is done in coding. If you want a program that will, for example, you give it a bunch of information like Google, you ask it a question and you want an output where it answers your question, something needs to be done there. And that is this idea of a black box. And in this black box, we think about it as an algorithm, that this thing that is being done can be anything. It can be analyzing data. It can be uploading something to the internet. It can be anything, right? Or in a non-technical example, this idea of driving the car. This could be your directions. This can be your lessons where you actually learned how to drive, where which roads to take, which turns to take, right? And this algorithm represents what will help you get from the information you give, the input, and the information you want, the output. So when we put this all together, we get our black box theory, which is the input, and then we have our algorithm, which is using what we give it to give us a desired output. So it's this relationship where the algorithm uses the input and uses everything we give it, but does more to then get an output. Because if we do nothing to our input, it stays the same. So the algorithm is making changes and building on the input and giving us more. Does that kind of clear things up? Okay. So now we will just begin discussing Scratch. So this is what Scratch looks like. In essence, it is on the left, we have all our block code. So we're going to call them block codes, which is, this is the same thing as writing it out, except it requires a little less, knowledge of how to actually code. So on the left, we have our block codes, which can be dragged into the center panel. And on the right, we have what we're going to call our sprite. All the sprite is a symbol that is performing the actions, and it can be anything. In the case of this example, it is the cat, because that's how the program does it. But you can make a sprite anything and program it to do anything. So, comparing this to actual coding is a very important idea, because it's the same thing in essence, except in coding, as you can see here in this example of C, you need to say exactly what to do. You can't just say, make it say hello. You have to say which languages you want to include. So in this case, we're using C, and then you need to say how to print it in what nature and everything. And then you need to kind of compile the code to allow a computer to read it. So block codes make things a little simpler, but are really the same thing. Here we can make the cat, we can drag over a block that says make the cat say hello. And here we are writing make it say hello. So it's the same concept. Now, before we begin, there are some important concepts to discuss. These concepts are as follows: functions, conditional statements, Boolean statements, loops, and variables. Now, each one of these has a different application to coding and the world of programming, and is very important in kind of making an efficient and neat code. Now, in coding, it's not always about getting it done. Obviously, you want to get a desired task done, but it's also important that things are neat and organized and compiled so they can do things efficiently. Because the neater, as we discussed with data analysis, the neater and smaller a piece of data is, the more efficiently a computer can process it. Now, we will first discuss functions. A function is a block of organized, reusable code that is for one single action. For example, this function here, this is using Python, is used to calculate the area of a rectangle. So this function has one clear and concise use. We have the length of the rectangle, 10.5, and we have the width of the rectangle. Here's our length, and here is our width. Now, all our function does is multiply them, because we're telling our function doesn't, or Python in the world of coding, it doesn't know what anything is. So you have to give it directions. This is your directions when you're in the car of how to get there. So I'm telling it that area is the length times the width. And then I'm telling it what length is and what the width is. And then it knows that it needs to calculate the area by doing the length times the width. And then it prints the results and gets the area of the rectangle, which in this case is written here because it got cut off. But when they're multiplied together, you get like 44.6. So there's not in the world of actions that needs to be done, there's nothing else really that this function does. So this is what makes it a function. It has one, it's very neat. You're telling it what the area is, and you're telling it the two measurements it needs, and then it does the math. So it's clear, it's concise, and it gets your one desired action done. Next up, we will discuss conditional statements. Now, conditional statements, I bet you've seen them before. They are this relationship of if something is true, do this. If not, do something else. So it's kind of this if then. So a keyword if you ever see an if and a then, you know it's a conditional statement. So in this case, we are saying we're classifying what letter grade a student got based on their grade. Based on their number grade. So we're saying if the score is a 90, then they got an A. If it's not a 90, so else, and if the score is an 80, then a B. And this keeps going until an F. And one of these options must be true. So it will keep going until it finds the true condition. We're going to call it a condition. So in this case, the student score is an 85, which means it is greater than or equal, right? We have a greater than or equal to 80 symbol. And then that means that the student will return a B. But let's say the student grade was a 75, then the 90 wouldn't have worked. So that would have crossed. It would have kept going down. So it wouldn't have gotten an A. The 80 wouldn't have worked. But since the 75, the 70 would have worked. So the system of a conditional is simply that you start at the top and you keep going down until you find your desired result. Now, there's always the case where none of them will work, right? So that's why we have else and if, because we want to make sure that if you're in the 60s, you get your D. But then once you're below a 60, it's all an F, which means there's no more if, it's only else. Else, if you have anything else, which means if you have none of the above, you will get an F. So a conditional statement is just this relationship of if this, then that. If not this, so like if something else this. So yeah. Destiny thing is just like Q basic. Do you have a question or? Yeah, but it's just questioning, and if the value to that question is incorrect, then it will keep looking for the correct value. And if it doesn't find one, it is told what to do. Okay. So we're going to move on. Sending a question in the chat. Is it just like a Q basic? Would you like to unmute and say ask a question or?
Good evening from here. Like what I'm asking is that is this is it just like a QBasic, like QBasic programming?
What you mean? What language?
Yes, a language.
Oh, so this is Python.
Okay.
Which we will be learning about. So this is I'm kind of using Scratch to begin our exploration into computer science, and then in the future I'll go into the different languages: C, C++, Python, and all of that. And yeah, so as an example, I've done Python here to show.
Okay, thank you.
Yeah. So, right, so we have our if, we have our original score, and then we have all these options of else. So because if the original isn't true, then we have all these elses or else ifs, and then we have the final else because there's no more if. If you don't have a 60, if you're a 60 below, there's no other option, you have an F. So these are our if-then conditional statements. Now we will discuss Boolean expressions. Just getting a question in the chat. Okay. A Boolean expression is an expression that evaluates to produce a result, which is a Boolean value. And a Boolean value is just a true or a false, a yes or a no. So let's say we want to check if a person is eligible to vote. They're either eligible or they're not eligible. There's no in between. So if if in order to vote you need to be above 18, which is stated here, and the age of a person is 20, this is Python again, by the way, then it says, so it's saying, so Python, the program doesn't know how old you have to be eligible to vote. So I'm telling it, is eligible to vote, you must be 18, and our person is 20. So the whole point of coding, this idea of coding is that a computer has no knowledge. That's what coding is, giving it the knowledge. Imagine you're trying to drive somewhere and you don't know how to drive and you don't know the directions. You won't get there. And it's the same thing with the computer. It needs this input in order to do its algorithm to give you its output. So I'm telling it how old a person is, I'm telling it how old he needs to be, and then I'm telling it what to do. So I'm saying again, here's a conditional statement. If is eligible to vote, which means because I told it what is eligible to vote means, 18, then it will print you are eligible to vote. Else, since there's only one other option, a Boolean expression, unlike a conditional statement where you can have a grade of an A, a B, a C, or a D, or an F, in a Boolean expression, there's only two. There's only a true or a false, which means you only have an if and an else, which means you're either eligible to vote, if eligible to vote, or you're under 18 and it's an else, and you are not eligible to vote. Does that make sense to everybody? I know it's a little, it's kind of just, yeah, some fundamental ideas that are important. Yeah, if you have any questions, feel free to just unmute or ask in the chat. Doris, do you have a question or just you understand this? Okay. Now, the next thing we will discuss are loops. Loops are very important because loops basically take what is they would just repeat code. So what we're going to learn when it's actually time to code is that writing code is very tedious. You need to tell it exactly what to do because the computer does not know what to do. So you need to give it exact directions of what to do. You need to say you need to do this, and this means this. So instead of manually writing out what everything is, so this is Python again, if we have a circuit that's instructed to print multiples of 3, I'm telling it do 3 times 1, do 3 times 2, do 3 times 3, do 3 times 4. And these will create all our multiples of 3, right? 3, 6, 9, 12, and 15. However, instead of doing that, look, instead of 1, 2, 3, 4, 5 lines of code, with just 2 lines, we can do the same thing using loops. We can say, for I, if it's in the range of 1 through 6, loop from 1 to 5. So now do print 3 times I. So instead of 3 times all these individual values, it gives it a variable. And then we give this variable of I a value, a range of 1 to 5. And then you say, print the multiple of 3 for each I. So for each possibility to multiply it, you're giving it a value, you're giving I a value. So this is why loops are crucial, because imagine you don't just want multiples, you want it, you're playing a game, you're using a website, and sometimes you need things to be done more than once, right? You just don't want something for a split second, you want it to repeat over and over. Instead of rewriting that code over and over and over, you can just say repeat 5 times, repeat 10 times, right? Or repeat and add 1 each time, repeat and subtract 1 each time. Like imagine you have a timer. Instead of doing do time -1, time -1, time -1, you can just say repeat and then time and then -1 each loop, each repeat. So this is why loops are crucial. The final thing we will discuss are variables. Now, variables are used to store information, like I said before, and they provide a way of labeling data. So that I was a variable because it represented all the different ways that you could multiply by 3 to get you could multiply by 3 to get multiples. So here's our example. Our user age, we have a user whose age is 25. And you might, going back to the voting example, you need to be at least 18. Our variable is this changing age. And in this case, our variable represents is equal to a 25. But as we saw in the last slide, our variable was a I, right? Which in a loop is a value that doesn't have a constant amount because it can be anything from 1 through 6, right? So the idea of a variable is that instead of giving something an exact value, you give it a temporary value, and then you can, anytime you want, assign it a value throughout your code, which is what is being done in this loop. Now, in the first class, no, it was a while ago, we discussed binaries. And binaries will continue to be important. Now, here is some C, which says hello world, okay? And this is what it looks like to a human. It's written out, and when you run this code, it will say hello world. Now here is a binary. Would anyone like to take a guess as to what this says? All of these binaries. I don't want you to manually do it, but just take a guess. In the chat or just say out loud. I would like a couple of people to take a guess as to what they think this says.
Hello world.
Yes, exactly. I see a couple of people have said hello world. Exactly. So many binaries, so many options between on or off are just to say hello world. And the reason this is because it's not just spelling out hello world. It's saying where to say hello world, how to say it, in what font size. It has all the information of this package of hello world that is so much more than just the letters hello world. And this is what Scratch, which is for kind of us to get started, will do for us. These blocks will have all of these binaries built into them. Now, when we actually code, we don't need to do it in binaries because we will write our code and then we will use a system, an extension of Python or C that will, in essence, compact all our human written code into a lot of binaries, which will make it easy for the computer to read. Because remember, a computer can't read all this. These are different letters, different colors, different symbols. So for a computer, it's much easier compared to reading this. It's much easier to just see a bunch of zeros and ones because the computer knows and can memorize and can come in every computer can know what a 0 and 1 is, right? So it's easier to do that than know what 100 different symbols are. Now, Scratch relies on 2 main symbols. A green flag, which means go, which kind of is the way we represent running our code, and the red flag, which means stop. And using these 2 buttons, the cat, our sprite, or whatever other character, we can drag these block codes and program it to do different things. Now, Let's say we want to say hello world using Scratch, right? Just hello world, very, very simple. Um, all of what we wrote in C, all of those binaries translate to exactly this. So it's kind of this interesting, uh, um, it creates this interesting comparison of you can either write all this, you can have all these numbers, or we can learn by using Scratch. Now, Scratch, we know it looks like this, and it has our palette for block codes where we drag into our code area. Then we have our sprite area, which is the technical term for a character in Scratch. And here we can control them, discuss where they move, discuss their size, and everything. And then we have our stage, where the code will actually be performed. Now, let's say we wanted to say hello world. Going back to this idea of the black box theory, we have our input, which is not saying, but just hello world. We are telling it hello world. And what is the algorithm? Can I have any some people share out what they think the algorithm is here? Because what do we want to be done? Feel free to just say it out loud or say in the chat. What is it? What is our algorithm? What is our direction? What do we hope to get as an output? Would anyone like to share in the chat or just say it out loud? Okay, I'm seeing someone say a green flag. Any other guesses? Any other ideas? Okay, it's hard. Okay, so I'm going to say I'm yeah. So yeah, a lot of good ideas, but our algorithm is simply another block code, which is say, because not only do we want this hello world, but we want it to be said, which will give us an output of our sprite, our cat, saying hello world. So this goes back to this idea of the black box theory. We are giving it an input of hello world, we are giving it a direction to say it, and then we are getting an output where our sprite is saying hello world. Our input, our action, our direction, and voila, our outcome. So now I am going to actually use Scratch with hope to kind of show more of the ways that this idea of the black box can be applied. So one moment, please. Okay, so this is what Scratch looks like. Okay, so yeah, as we've discussed before, it's whatever we have all our blocks, and then we have everything we need. Now, let's just move this out of the way. So to begin, we have our when green flag is clicked, right? That represents the go button. So in order to know when to start an action, we need to hook it up to something. So we're going to start by saying when green flag is clicked. Now, if we wanted to, what's an input you guys want? What do you want the cat to say? It can be anything, right? So we can hit say, right? And we drag that to under the green flag. Because so now when we click, it doesn't have to say hello, but we'll make it say hello world, right? We type that in. And now when we click the green flag, it says hello world, right? But now we can get so much more complicated. We can say, not only can we say something, but we can, let's remove that. Not only can we say something, but we can also ask something, right? So we can hit, for example, we can say under sensing, we can say ask what is your name and then wait. So now, once I click the green flag, it will say what is your name. And then here I can put in my name is Julian and hit enter. And now it knows my name. But what's the point of knowing, now it has this input of knowing my name, but what's the point of having my name if it can't do anything with it? So now it has an input, but it doesn't have any directions, right? It has the directions to ask, but not to go for it. So now we're going to say, once it knows my name, we're going to say again that it should say hello for 2 seconds. So now it knows my name and it will say hello. So now when I hit the green flag, it will say, what is your name? I will say, my name is Julian, enter, and it will say hello. But what about I'm Julian and it knows my name? So why can't it say hello Julian, right? Or why shouldn't it? It can say that. So if I go if I drag another hello, it will do everything in order. So first it will ask my name, then it will say hello, and then it will say, in this case, hello again. But instead we can go to variables. Sorry, not variables. Well, it will be a variable, but our answer, which we learned about these variables, it's this ever-changing thing which can always be assigned a value. So in this case, our variable is assigned the value of whatever name we put in. So if we now hit the green flag, it'll say, what is your name? I'll say my name is Julian. Then it will say hello for 2 seconds, and then for 2 seconds it will say the variable, which is Julian. Does that make sense to everybody? Now, to apply this back to the black box theory, would look like this. Right. Would look like this. We would have the ask, what is your name, and wait. Right. So it has an input of what is your name. And then we have our algorithm, which does anyone have any ideas of what the algorithm is? What is it doing with this information? It is asking and waiting, right? So just like it is saying the hello world, it is asking and waiting for the what is your name. And then as an output, we get a result of hello and then our answer, our variable, which in this case was the name. So applied, our whole black box setup looks like this. It has an input of what is your name, but it needs to know what to do with that information. So it will ask and wait that. And then as an output, we'll get hello and then an answer to the algorithm. I know that was confusing and a lot. So does that make sense to everyone? Or do you want me to repeat it? Anyone? Yeah, you have a question?
Please repeat. I'm lost.
Yeah, okay, I'll repeat it. So, how far back do you want, can I start here? Yes, sir.
Na Thomas, to stačíme go skłagi testa, ka go agoya.
Okay.
On est trust home. That kine we I just chatted her now. See, I'm at the moment. See, no.
Okay, so we have going back to Scratch, we have a system that will first ask for our name, then it will say hello, and then it will say the answer to the asking. So when we run this whole thing, when we hit our green flag, it says, what is your name? Right here. Can you guys see that? Where my mouse is? You guys can see that, right?
Yeah.
Yes, so here it asks, it says, what is your name? Okay, so I will write in here, Julian. because that is my name. But the answer to that question also becomes a variable. Oh, one moment. So I write Julian here. And now that variable is used to first say hello and then say my name. So the variable of my name, which we discussed before, is being filled in here and given a value of Julian so it can say hello, Julian. Does that so far make sense? Yeah? Okay. Then, if we apply this idea back to the black box theory, and we say our original input, or not input, but original the block we're using is ask for name. So we are asking what is your name and waiting, right? So applying to the black box theory, where we have our input, our algorithm, and our output would look like this. We have an input of asking for the name, because that is what we are giving it. So we are giving it the name, right? That is the information we are giving. And we are also giving it a directions. We are giving it this algorithm, just like the direction of a car, to this any direction, right? If you want your output to be sliced apples and you have an input of an apple, your algorithm is chopping those apples. Any kind of direction would be to ask that and wait, right? And then as an output, our result, what did our sprite say in the end? It said hello and then my name, the variable, the answer. So our total thing looks like an input where we give it this information. It knows that it needs to ask it and wait, and then it will say it. Does that make a little more sense? Does that make a little more sense? Or do you want me to, I can repeat it again? Anything? If not, then we will move on. Now, notice how it said it separately. It said hello, and then it said Julian. And why can't we integrate that to say both? Why can't we make it say hello, Julian, just like it says hello, world? Well, luckily, Scratch has a feature that allows that to be done. So we will first ask, what is your name? And then instead of saying hello and waiting and then saying the answer, we can just say, and then we can use an operator, which is like mathematical or adding or subtracting or any of that. And we can say join, okay? We can say join. And then we can join, just like here it says join apple with banana. Instead, we can join hello, comma. And since we don't know what name it will say, we can make it join it with the answer. So now when we click the green flag, it will say, ask, what is your name, and wait. And it will say a joining of hello and the answer for 2 seconds. So let's try. We hit the green flag. It says, what is your name? I click Julian, type Julian, and it says, hello, Julian, for 2 seconds. And now, did you notice, I'll change this to some more time, to set 10 seconds, for example, so that you guys can see. But did you notice how in between the comma and my name, there's no space? And for example, if we wanted to look nice, we want a space. So if we want to do that, we would simply, right here after hello, we would insert a space. So I'm going to put my keyboard where I'm going to put my mouse where hello is and type hello, comma, and space. So now if we run it again, it'll say, what's your name? I'll say Julian, and it'll say hello, comma, a space, and Julian, which is exactly what we wanted. Now, looking at the black box theory with this, becomes a little more complicated, and I'll try to go over it very slowly and explain it a couple of times. But the black box theory with this has an input of saying we give it the information of hello. It doesn't know what hello means. It doesn't know it's a greeting. So we tell it hello, and then we give it our answer, right? And what does it do with these two things? It joins them, right? Because we have them joined together. Correct? So we're giving it these two words. We're giving it the hello and the name, and we're telling it to join them, which means it gives us an output of hello, Julian. But now it goes more, because did we just end with hello, Julian? No, we ended with the sprite doing something with that. So we have this algorithm where we tell it to say hello, Julian, which means our end is the sprite saying hello, Julian. So instead of just, it gets a little more complicated here, where we have our input, our algorithm, and output, except we kind of have a loop in a sense, because we have our original input where we give it our hello and answer, and we tell it to join these two, and that new output acts as an input for the next kind of set of things to do, where we tell it to use this new input, which used to be the output of the last problem, and say that with the sprite, which gives us an output of the sprite saying hello, Julian. Does that make sense? Are there any questions? I'm going to stop now for questions. And then I'm going to go back to Scratch, and we can use it as a group a little more. And I can show you guys some more features that can be done. I want a couple questions if anyone has any questions. So everybody, ask in the chat or unmute. In one question in the chat. Let's see.
Sorry, Julian. I'm sorry to take you back. I'm almost lost. I'm trying to catch up and you're moving.
I'm sorry. I think you're cutting out your sound. If you could repeat that or ask in the chat, I'm happy to answer your question. I understand that this is a very complicated topic, and even when I first learned it, it was very difficult for me to understand. So,
let's just grasp when I want to grab one, you move to another one. I'm lost. I won't lie to you, please.
What the graphs mean?
So when I want to catch up one, you move to another. That's what I mean.
Oh, yes. Okay, I'll explain. I'll go back to the first one. So, do you understand what the black box theory is?
Yes.
Yes. Okay. So we are applying the black box theory, which is this idea of an input and an output, and what needs to happen in between those two for our desired outcome. Do you understand that as well? Does everyone understand that?
Yes, I do.
Yes, very good. Now, in order for a code or a system to do anything, we need to give it both something to work with and a set of directions. So this can be thought about as driving a car, right? It needs instructions. It needs the actual car and the engines and the fuel to drive, and it needs the directions and the instructions of how to drive. So this can be thought about the input and the algorithm, right? So our input, what are we giving this system? We're giving it both our name and the word hello. We're telling it to say hello, right?
Yes.
Okay, so our input is both hello, the word, and the answer. I see you guys in the chat. I'll answer you guys in a moment. Just going to finish. So then what are we telling it? What direction are we telling it to do with these two inputs? Does anyone, this is for everyone. Does anyone have any idea? What do we want the algorithm to do with these two words, with both hello and the name?
We want the algorithm.
Yes, I heard some people say join, and in the chat, and some Doris saying to join. Exactly. Which means our algorithm, our set of instructions is to join the two. And what does that give us for an output? It gives us, instead of saying, remember where it said separately, hello, and then my name, now it will join them. So it will say all at once, hello, and my name. Yes, I'm seeing a lot of people in the chat saying join. Do you understand this? Does everyone understand this so far? So we have our input because we're giving it these two words. We have our algorithm because we're giving it instructions, which is to join the two. And then we have our output, which is the two inputs joined together. So the whole point of an algorithm is it's a set of instructions of what to do with an input, because you can give a computer any information, you can give it anything, but it needs to know what to do with this information if you want it to be useful. Okay, I'm seeing people say yes. Please stop me if you don't understand. Now, this output of Julian isn't our final output, because once we have joined the two names, what more do we need to do? Just in the chat or out loud, feel free to say it. What more do we need to do?
We
Correct.
need the
Yeah, I'm seeing people say in the chat, I'm seeing people saying to say it. Correct. So if we join the two, we'll never know. Yeah, it'll be joined, but we'll never see it. And remember our sprite, our cat actually said hello and my name. So we use what is the output of this algorithm, right? Because it always moves. The flow is this way. We use what is the output of this algorithm to become the input to the new one. So now this becomes an input, even though it used to be an output, and we give it instructions to say it, just like people said in the chat. We give it a set of instructions, which is to say it, and then we get a new output. Even though this was our old output, we get a new output where it's being said, which is our sprite saying, hello, Julian. Does that make a little more sense to anybody? To everybody? Well, if you have any questions, please say something in the chat. Okay, makes sense. Great, I'm glad. Now, okay, so I'm going to go through the chat now and see if there's any other questions. So, how do I install the Scratch programming language on my computer? So, yeah, it's actually a web application, so it can be very easily downloaded on your computer, and I will send the link. Scratch. Okay. Any other questions? So basically what you're saying is that the algorithm collects the input, and from the input, it tells the output what to do. So Yeah, so the algorithm, we are determining what the algorithm will be. So we are giving it instructions. So we are giving it the hello and the Julian, and we are telling it to say it. So the algorithm, and then we get an output where these two things are being said. So it can be thought about as the combination of the two. So it means that we need to set the input for hello, Julian, twice with algorithm for join and say. So obviously that can be done. So we can say both, join the two and then say it, or we can, because in Scratch it's being said after each other. We have it where they just are said all in one circuit. So if we switch back to Scratch for a second, so here we have it asking what's your name, and then we have it joining them and saying it. So instead of having them join and say separately, we have that all being done at once, which means no, it doesn't have to be said 2 different times. It's asked for once. Only once do I have to say, my name is Julian. And automatically it combines the two and at the same time says it. Does that make more sense? Okay. Now, does anyone have any other things they would like to see being done with Scratch, or any requests? Because I was hoping to kind of just show some of the things that can be done before I compare it to see. Can you use Scratch to create a website? So Scratch is more a web-based tool that controls this sprite over here. So the idea of Scratch is to kind of learn the basics of how these block codes work. So unfortunately, no, you cannot create a website. However, you are not limited to using just this cat as your sprite, right? This can be anything. You can have a game where you are flying a bat around and you need to catch different things with your bat. Then your sprite can be a bat, and then you can program it to when you move your arrow keys on your computer, or you click a certain key on your phone, you can program it to move around. And in fact, I'm going to do that right now, but with the cat, just to show. So we're going to start by clearing. We're going to start by clearing all these things so that the program doesn't get confused. Okay. Okay. And then, so to clear, we simply just drag to the left. Okay. So now we have a fresh, clean slate. Now, I'm going to program it that when we hit the green button, we always need to start with when the green button is hit. When we hit the green button, this sprite will begin to move according to my arrow key. So I'm actually going to make the sprite a little smaller. So I'm going to make it size, let's say 65. So now the sprite is smaller. And now I'm going to program it. And I'm going to say, after I hit that, to wait 2 seconds. And I'm going to say forever. So while the thing is clicked forever, it should say hello. So during the whole, where is it? It's under looks. So during the whole game, our sprite will be saying hello. So now when I click the go button, it's going to wait 2 seconds, right? It's going to say hello, and it's not going to start saying hello until I hit the stop button or until I run a program that makes it stop. So now we can go even more. I can say, I can control it, and I can say, I can make it move in direction. So I can say I can say move 10 steps. So now it will say hello and it will move 10 steps. But now I don't just want it to randomly move. I want to choose which way it's moving, because now it just crashed into the wall and no one can see it, right? So we're going to hit stop and it's gone. So one thing that's always important is we need that thing to get back. We need the cat back in the middle of the screen. So to do that, we're going to say every time we start it, let's move the sprite back to the middle of the screen. So in order to do that, we're going to say we're going to go to motion and we're going to say go to 0, 0, right? Because this is a grid. So now when we hit this, it will go to the middle, it will go to 0, 0, and it will randomly move. Does that make sense so far to everybody? Yes. If you have any questions, just stop me or ask in the chat. Anything is good. Now, to keep going, we would now like to control how it can be moved. We don't just want it to randomly move. So instead of move 10 steps, we're going to say change X by 10. So we have the X axis and the Y axis. So now we need to decide what will make the X change by 10. So I want that to be my left arrow key, right? Because that will make it move by 10. So now I need to find the one under control. Where is it? I need to say when arrow key clicked, which 1 second, somewhere here. Where it will be when arrow key is clicked, when left arrow key is clicked, then move change by 10. I'm just trying to find it right now. It should be under motion, but or control. Okay. And now okay. So so I'm just gonna find it and then I'll come back. But I just want to discuss the importance of all this before I keep going. And the biggest thing that you should take away, and I want everyone to take away from this, is this idea. 1 second. Is this idea that all of this, what we're doing on Scratch right now, in some way or another, can be translated to a real coding language. So here in C, I have set it up that it will say hello world, right? Just like it said with all those binaries, just like it's saying on the right with Scratch. And just to say hello world, where in C we just had to drag, in Scratch, we just had to drag over one block. Just to say hello world, we have to have how many lines of code? 6 lines of code. So the hope is here that we can kind of create a basic understanding of how generally coding works, and then we can use that to apply to writing real coding languages. Does that make sense to everybody? I'm just going to find.
Yes.
Yes. Does anyone have any questions? Does anyone have any questions? Okay. Oh, I'm seeing in the chat. Okay. Someone is saying to repeat it. Yeah, of course. So the idea of everything we're doing with Scratch is this hope to, in a way, find a connection to Scratch, to real coding languages. With that, in Scratch, all we had to do to say hello world was drag over one block code, and it had everything we needed it to do in it. It said how to do it, where to do it, when to do it, etc. However, in C, to say the same exact thing, and we don't even have a cat to say it in C, it will just say hello world. We have to do 1, 2, 3, 4, 5, 6 lines of code. So the hope is that we can kind of create a basic understanding of the world of coding and the nature of which it needs to be done before we actually go into learning languages. Does that make sense?
Hi, Julian. So just to confirm, so what I'm looking at now, what you're calling C, so this is probably a naive question because I'm totally new to coding. So code, whatever that URL is, that is your coding sort of like platform, is it? And then Scratch is your dummy sites. Is that the way to
So yeah, in this
understand?
case it's I'm doing it on the web just because it's easier. But usually you download a coding platform. So the one I really like is called VS Code, and you download it onto your device, and then you can write codes and control it in the terminal. And we'll go obviously into more detail about this when you start writing code. But Scratch, a program which is also on the web, and the link has been sent in the chat, and I can resend it.
Yeah,
Is
I already
very
have
similar.
created I've actually gone in and signed in actually
Oh,
onto it.
very nice. I'm glad. And I hope you guys all, or for those of you who, yeah, can take some time and kind of, it's just play around with it and kind of understand how the world of coding works. That you can't just use your own language and tell a computer what to do. You need to use their language. And that's kind of the understanding I'm trying to create with coding languages, because you can't just say, like, you can't just write say hello world wherever I want. You need to use the exact language that a computer will understand. You need to say this number symbol, and then they include s standard io.h, and then you need to say printf hello comma world, and then there's / in the end, right? You can't just say however you want. So the goal with Scratch is to understand that you need to understand the way a computer wants things to be said and will understand things.
Brilliant, thank you.
Yeah. So to go back to Scratch, we're going to use actually a conditional okay. So yeah, we're going to use a conditional statement, which is if then. So we're going to say if, and then a certain key is pressed. So for example, this can be our right arrow. Then we want to change x by 10, right? So obviously, if we click this now, it's not going to work. I'm clicking my right arrow, and it's not working because it's not under the green flag. So then we need to find a green flag. So when that is clicked, it will do that. So now we're going to click that, and I'm going to click my left arrow, and it's still not going to do that. And the reason is because it's only doing it the moment the green flag is clicked. So to fix that, we need to say, do this forever. So as you can see, I'm not writing any code. I'm only dragging these blocks around, but still do I need to use the computer's language? Still do I need to say this forever is only going to fit in this if and can be dragged here, right? And this is why I hope that I've sent the link, and I hope that all of you can play around with this, because now once I click it and I click my left arrow, as you can see, if you can see my camera, when I'm clicking my left arrow, it is moving left, right? And none of my other arrows are programmed, so I'm going to just quickly duplicate that and say when the left arrow is clicked to change x by -10. Sorry, I meant right before. So now if we click our start button, forever will it be looking if I'm clicking my arrows. So now I'm clicking my left arrow and it'll move left, and I'm clicking my right arrow now and our sprite will move right. And then to do up and down, once again, I would duplicate twice. But instead of changing x, I'd want to change y. So I would say change y by 10. I would throw that out. And I would say change Y by 10. So now do up and down and negative. Okay, so now when we click start, forever it is checking whether I am clicking on my keyboard, right? So I have my keyboard here. And it is now forever checking that when I click up, it will go up. As you guys, can you guys all see that? And when I click down, it will go down. And when I click to the left, it will go to the left. And when I click to the right, it will go to the right. And if you guys can, and I'll also send a picture, but if you guys can, take a screen capture of this and kind of, you know, try to recreate it and make your own edits and make it that, you know, every time you hit the edge, we can now program it that every time it hits the edge, it will go back to the middle and you'll reset. And then we can make a full game out of this, or you can make anything. And what I hope you guys take away from this, if there's one thing you take away, I hope you take away this idea that in coding and in programming, you need to use the computer's language. You cannot use your own language. I can't just say, go left when I hit this arrow, go right when I hit this arrow, go up when I do this, and disappear when I hit space. I need to say, if blah, 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 then blah, 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 right? I need to use exactly how the computer will understand it. And I hope that Scratch builds that understanding before we move on to actually writing code. Does that make sense to everybody?
Yeah, it does to me. One question. So did you,
Yeah.
is it your simple Control C, Control V that you used in is it duplicating each of those codes?
Oh yes. So
All right. Okay. So
of course
literally
I can do a control click, which will allow me
I
to
see. Yeah.
both
So
delete
you
it,
right
add,
click and then you get those
yeah,
options. Okay.
and duplicate. But then I can also I'm clicking on it right now and I'm clicking control C. And then
Yeah.
if I click somewhere else and control V, it will duplicate.
And it goes
So
on.
both
That's it.
options, yeah.
Brilliant.
And obviously duplicating is very helpful, but there's also more efficient ways to do it, like looping. So instead of having all these things, I can say forever and then put these all inside the same forever, right? And while
Mhm.
in the case of this game, it does the same thing, in the case of efficiency and when you're looking at code, let's say you made a mistake and then you had to look through all these different things, instead you could just look through one neat organized block. So that's why being neat, and this is something I also want to teach before we begin coding, is that being neat is not just for the computer, it's also for you, because when you have to go fix a mistake, when you have to go change something, if it's nice, neat, and approachable and presentable, you yourself, it makes it easier to fix. So now I've put them all onto the same thing and kind of created a loop in essence, and the system still works, right?
Yeah.
Yeah.
Mhm.
So if that's it. Okay. Yeah. So yeah, I would like you guys all before next week, if you can, of course, to play around a little bit with, if you have the opportunity to play around with with this idea of Scratch and this idea of using the language of a computer to do something. But other than that, that is all I have for today. That is all I have planned for today. So yeah, if you have any questions before leaving, I'll stay on the call for a little bit, and this recording will be posted to my YouTube channel. And but I yeah, I hope you like took a picture, and if not, I'll send one out. And I hope that everybody kind of gained an understanding of using a computer's language instead of using your own. I know it's annoying, but I hope we kind of built some prerequisites before before it's actually time to write code. And I'm looking forward to doing that with all of you as well. Yeah. So if there are any questions, feel free to unmute. Oh, can we practice all these with a mobile phone? So I believe there are some programs. Let me just look right now for you all. I think the actual Yeah, so it's on touchscreen. It is you are able to do it, and there are a lot of games actually and programs that work better because of touchscreen, because you don't have to use the keys and you can touch. And there's even ways to make it that your sprite will follow your finger or will follow your mouse and will go anywhere your mouse goes, right? And you can set speed. And I kind of want you guys all to play around with this and understand, not just for the sense of programming a game, but to kind of have fun and move around the sprite and change the sprite, right? And all the different things you can do. So yeah, I hope you guys have fun with that. And are there any other questions?
Hi, Julian. Another silly question you might think. So the sprite, is that the name of the cat, or is it, the screen on Scratch is so you got three screens where actions are on the far left, and then it's kind of like a board in the middle. Is it the last screen that you call sprite, or is it the cat and its actions that is called sprite?
So the sprite is just a symbol for the cat. So or the name of that symbol, which in this case is a cat, because
Okay.
it's that's just the symbol chosen by the people who made it. But yeah, the sprite
Okay.
simply represents the thing doing the actions, and that can be changed. There's a lot of games out there where they've changed it completely and there's no cats to be seen, right?
Okay, so am I right in thinking that those three, divisions on Scratch is literally your input, the algorithm, and then the output? Is that the way to look at it?
That's those
So
three divisions.
so I mean, so on the board, on the Scratch board that we see, the actual app, you got
Yeah.
three parts to it. So is that literally representing your inputs, your algorithm, and outputs?
Not, yeah, in a way, actually. So you have all these
Okay.
options of what to give it, and
Mm-hmm.
then you have the output of on the stage of what is actually done. Yeah, it's a good way to think about
Right,
it.
okay. Thanks. Just getting my head around this whole thing because
Yeah,
coding
no, it's
seems
very
like
complicated, and obviously
yeah.
we'll review it next week, and
Okay, cool.
I can, yeah, and there'll be a recording to this.
All right, thank you.
Okay, well, enjoy the rest of your weekend, everybody.
Thank you,
And
you as well.
yeah.
Bye, everyone.
Thank you so much, Julian.
Yes.
Thank you so much, Julian.
Yeah, thank you.
so
I
much.
hope you.
Thank you. Thank you so much for the lecture.
Thank you. I hope you.
Thank you so much, Julie. Much.
Thank you so much.
Thank you so much. Thank you so much.
Yeah.
Thank you so much.